Hi students, welcome back to my channel Evolve Solving Physics. Today we are going to discuss resolution of vectors into rectangular components in 2 dimensions and 3 dimensions. That is 2 rectangular components and 3 rectangular components. What is resolution of vectors? So resolution of vector means, for suppose, let us consider 2 dimension, that is xy plane, and this is the origin. So let us consider an object is moving from origin to this point r, to the point r. So this represents magnitude and this is the direction. So consider as a position vector r bar. So this is a position vector r bar, and the magnitude here, the magnitude is considered as r. OP is equal to r. This is magnitude of OR. Magnitude means length. Magnitude means length traveled by the object. Length of object is R. For O to R, capital R, the length traveled by the object is small r, and the vector has magnitude. There is a direction we considered as position vector r bar. Now draw a perpendicular to the x-axis and y-axis. Draw the perpendicular lines towards x-axis and y-axis. That is considered as P. So this is the perpendicular to the x-axis, and this will becomes perpendicular to the y-axis. So here the vector r bar is resolved, means divided into two components, that is OP and OQ. And for suppose, let a distance traveled by the body from O to P considered as small x. This is the magnitude traveled from O to P. The distance or length traveled by the object from O to P is small x, and this is the direction. And OQ, the distance traveled by the body from O to Q, is considered as small y. This is the magnitude along y-axis from O to Q. So this is the length. So here we are drawing two perpendicular lines towards x-axis and y-axis. Here by drawing perpendicular lines we will get two components, two resolved components, that is the resolution of vector in two rectangular components. How we can write that two rectangular components? So, and I'm considering an angle towards x-axis. Here theta is the angle made along the x-axis. So now consider r bar vector in xy plane. Here r bar vector in xy plane and makes an angle theta with the x-axis. So the r bar vector is making an angle theta with the x-axis. You know that for xy plane, for x-axis the unit vector is I cap, and for y-axis the unit vector is j cap. For z-axis the unit vector is k cap. We already discussed in previous class. So for x-axis the unit vector is I cap, and for y-axis the unit vector is j cap. So I cap, j cap are unit vectors along xy axis. Now from point R, I said that resolution of components means dividing the components, that is RP and RQ. That is, now from point R draw RP and RQ. These are perpendiculars to x and y axis respectively. So you can observe that here O to P, the magnitude is x. So OP is equal to x and OQ is equal to y. Then OP bar means it's a vector. OP bar means I wrote only OP has magnitude, that is x. I'm writing OP has vector. How you can write means x I cap. You can observe that x is a magnitude and this is the unit vector along x-axis. combination of that you will get the OP bar. So OP bar is equal to OP in the form of magnitude is equal to X, but OP bar I wrote here. Bar represents it's a vector, so X I cap. And similarly OQ bar means OQ is Y. Bar represents direction along which unit vector? J cap. J cap. So from law of vector addition, so with the help of R bar, with the help of OR, we got RP and RQ. So here the object is moving from O to R, O to P and O to Q. So first the object is moving from OR. So OR bar is equal to OP bar plus OQ bar. So what is OR bar? OR is small r, that is magnitude. Bar represents R bar. R bar is equal to, why I'm not taking any unit vector here? There will be only unit vectors for axis, x-axis, y-axis and z-axis. But R bar is a vector along xy plane. It is, the vector is being between xy plane. So there will be no unit vector between two axes. There will be unit vectors only for individual axis. That is x-axis for I cap, y-axis for j cap and z-axis for k cap. So R bar equals to OP bar means x I cap plus y j cap. This is the so x I cap and y j cap are called the x and y components of the vector. Which vector? R bar vector. Vector R bar. So by drawing perpendiculars we got x and y components. Xi cap and yj cap are xy components of vector R bar. So R bar is position vector. We have discussed already in previous class that small r represents position vector. So position vector means xi cap plus yj cap for two rectangular components. Similarly, position vector for three rectangular components. Three rectangular components means xyz components. So here x component and y component as xi cap and yj cap. Here three rectangular components means x comma y comma z components. Z components. So that can be written as R bar equals to xi cap plus yj cap. This is two rectangular components, but we are discussing three rectangular components now, plus zk cap. This is the position vector along three rectangular components, and xi cap, y, comma yj cap and zk cap are the x yz components of vector R bar. So now we are going to find the angle for two rectangular components. I said theta is the angle made along x-axis. So how can we find that? So you can observe one right angle triangle here making an angle theta. This is a right angle triangle. So ORP is the right angle triangle. So you can observe here there is one right angle triangle here, that is OPR. So from this we can write that. So I said the magnitude of OP is x. So this OP is parallel to QR. So this magnitude also becomes x here. So the parallel terms magnitude will be equal. So as OQ is magnitude is y, so PR magnitude is also will becomes y here. So from right angle triangle, from from triangle OPR. OPR. So you can write sine theta here. So this is theta. This will becomes opposite. This will becomes adjacent. This becomes hypotenuse. So and OR magnitude is small r. So sine theta means opposite by hypotenuse. What is opposite here? Y. By hypotenuse is OR. So PR by OR. PR by OR. PR is Y by small r. I am writing only the magnitudes here, not vector. If you write vector, we should mention I cap and j cap. So we are finding angle here. So here theta is the angle made along x-axis. So here we are going to find the angle. So for that I am writing sine theta and cos theta. Cos theta means adjacent by hypotenuse. What is adjacent here? OP by OR. What is OP? X by R. So I want tan theta here. Tan theta means sine theta by cos theta. What is sine theta? Y by R by X by R. Make the reciprocal. Y by R into R by X. When you make reciprocal, the denominator will becomes numerator and numerator will becomes denominator. R will be cancelled. So Y by X. So tan theta equals to Y by X. But we want angle theta here. Theta equals to tan inverse of Y by X. So this is the angle made along x-axis. Y represents the component, the magnitude along y-axis, and X represents the magnitude along x-axis. For suppose I am taken this as O, P, Q. I am taking it as OP has 3 and OQ has 4. So this is the angle theta. So you draw the perpendiculars, then theta equals to tan theta equals to Y by X. Here what is Y here? 4. And what is X here? 3. So tan theta is equal to 4 by 3 and theta equals to tan inverse of 4 by 3. So this is the angle made along x-axis. This is angle made along x-axis. Here cos sin theta is written as Y by R. So send R to left hand side, it will multiply. R sin theta equals to Y. Y equals to R sin theta. Similarly, cos theta equals to X by R. R cos theta equals to X. First, suppose they said to write the position vector R bar in terms of angle. So we have R bar as xi cap plus yj cap. If they said to write you this position vector in terms of inclination, angle, so you can write it as R bar equals to X is R cos theta I cap plus R sin theta into j cap. This is the position vector in terms of inclination, that is angle along x-axis. So this is vector R bar in terms of inclination, that is angle theta. I said that OR is R, small r is the magnitude of vector R bar. So how you can find the magnitude of a vector R bar? So magnitude of R bar. So how we can find the magnitude of R bar? You know the triangle OPR. OPR. What is Pythagoras theorem? Pythagoras theorem is from OPR. Pythagoras theorem means hypotenuse square equals to side square plus side square. These are sides here. Sides. So hypotenuse whole square equals to side square plus side square. So here we are going to find the magnitude of a vector. So What is hypotenuse here from figure? O, R, P. This is theta. This is R bar. This is side. This is becomes side here. This is X side and this will become Y. So XY na. So hypotenuse is here. OP, OR whole square is equal to OP whole square plus PR whole square. So hypotenuse square is equal to side square plus side square. This is Pythagoras theorem. So OR whole square. So you want OR here. What is OR? OR is magnitude of a vector. So OP means R x square plus PR means y square. So whole square. As I am sending square to right hand side, it will become square root. So x square plus y square whole power 1 by 2. This can be written as square root of x square plus y square. What is OR here? OR is small r. Small r is equal to x square plus y square. Small r represents magnitude of a vector, that is r bar is equal to under root x square plus y square. In this way you can find the magnitude of a vector. So r equals to under root x square plus y square. This is the magnitude along two rectangular components. How we can write the magnitude for three rectangular components? Means r equals to under root x square plus y square plus z square. So how you can easily find the magnitude of a vector? Means the magnitude can be found as the square root of sum of squares of the components of the vectors. So square root of magnitude can easily calculated by making square root of sum of squares of components. Sum of components are sum of magnitudes. Squares of magnitudes of x, y and z axis. Magnitudes means this is magnitude. OP magnitude is x here. So sum of squares of magnitudes of x, y, z axis. So easily you can calculate this. So this is how generally you can write mathematically a vector and angle, and how you can calculate the magnitude. By using this topic, in next class we are going to discuss the problems based on this topic. In that class you can easily calculate magnitude and how easily a vector can be written and how easily we can write an angle for that. So just simply remember that for vector r bar, its magnitudes will be x and y along x y axis. So for r bar vector, x and y are magnitudes. Magnitudes means length traveled by the body along x and y axis. For suppose if we take a vector a bar, what will be the magnitudes along xy axis? So ax and ay are magnitudes along x and y axis. Just remember that a bar is a vector and its magnitudes will become ax and ay. A suffix x and a suffix y. So these are the magnitude along x and y axis. For suppose if you take p bar as a vector, its magnitude along x and y axis is px and py. So for r bar only, for position vector only, x comma y are the magnitudes along x and y axis. So here we are considering capital A bar, so its magnitudes will becomes along x and y axis are ax and ay. So p bar means px and py. So if we take f bar as a force, is a vector, its magnitudes along x and y axis will be fx comma fy. So in this way you can write the magnitudes along x and y axis. As you know the magnitude, you can easily write the vector form, that is f bar equals to fx, it's along x axis, now its unit vector is I cap plus fy j cap. So for this you can write a bar as ax I cap plus ay j cap. For p bar, px I cap plus py j cap. In this way you can easily write the vector mathematical form. If you have any doubts, please comment me in comment box. Please like, share and subscribe my channel. Thank you.